Okay, so let's take a look at the problem. The first problem. Okay, the simple random sample of 5 months of sales data provided in the following information. Okay, so basically they're asking for develop a point estimate of the population mean, right? And then the next problem is develop a point estimate of the population standard deviation. Okay. So let's just summarize things that we need to know to solve this problem, right? Let's just first look at the notations, right? So we have a population parameter, right? And then we have the point estimator, right? The point estimator, right? The population parameters, the first one is a mu, which is the population mean, right? And then sigma, which stands for the population standard deviation, right? And finally, the p is the population proportions, right? And for the corresponding point estimation, right? Estimator, you can get these estimates from what? From a random sample, right? This is something that you can get from the random sample, right? Oops, sorry. Random samples of size n, right? Size n, right? Okay. So for the mu, which is population means, we have something called x bar, right? This means the sample mean, right? Okay, the next one is for the sigma, right? And then we have a sample standard deviation, right? And then equation for the sample standard deviation, right, is that the it's first if we have n, right? If the size of this size is n, right, then it's n minus 1. Okay, so it's n minus 1, and then we have a sigma, right? And then xi minus the mean, sample mean, right? Sample mean square. And of course, if you look at the sigma, it's like I is equal to 1 all the way to the n, right? So that's, I'll just abbreviate as a sigma, but actually the sigma it's this, right? Okay. And then this p bar, right, is corresponding the notation, right, for the point estimator, right? So so we can get this x bar, s, and p bar from a random sample of size n, right? Okay, so now if you look at the problem asks you to find the x bar, right? The point estimate of the population mean. And then this is relatively easy because you have a 5, so the size is n, right? So we need to find the average, right? So let's see. Okay, so so you just type this number 94, 185, 94, 92, right? So the x bar, so you have to find the sample mean, right? That's the point estimate of the population mean. So to find that, we can use the the average, sorry. So the average, right? And then just this, right? So the answer is a 93. And develop the point estimate of the population standard deviation. There are 2 ways you can get this value. The first one, I want you to know the both, okay? And the first way is just use this equation. So to find the point estimate for the population standard deviation is root. And then we have what? 94, 100, and what else? 85, right? 94, 92, right? So basically n minus 1, we have how many of them? This n is 5, right? So 5 minus 1, and you know that if I just expand this sigma, and you know that this is x1 and this is x2 and this is x3 and etc., right? So this is the x4 and x5. So if we expand this this equation, right? Numerator, right? Basically, this, you know, the sigma is a sum, right? The sigma is a sum. So basically, 94 x1 minus x bar is what? What is our x bar? X bar is 93, right? Okay, so 93, and then square, and then the next one is 100 minus 93 square. By the way, just keep going, right? This is going to be long equations, and then etc., right? So I'm going to skip this. So you can find this value manually, right? So you can use the calculator and then find this equation. Another way is what? Use the Excel spreadsheet, right? So, okay, so now standard deviation, right? So standard deviations, oops, STD, right? And but you know what? This is a sample, right? So you should not use the standard deviation.p. Instead, you have to use the standard.s. The s means a sample, right? So scroll down, right? And then the value is 5.3. The 5.3.85165. However, they said round your answer to the decimal places, 2 decimal places, right? So please be careful when you enter this number, right? Okay, so I'm done with the question number 1. Okay, by the way, okay, so let's just summarize. For this, we can use the standard deviations. You know, we can use Excel, right? And standard deviation, what is the functions? Let's see. Standard stdev.s, right? stddev.s. So be careful. We have to use s, right? Because we are looking for the sample, right? So standard deviation for the sample, standard deviation s. Okay, so I'm done. Okay, so now let's take a look at the next problem. So what is given is, let's say the mean amount of deduction of this population of taxpayers is $16,642, and also the population standard deviation is given, right? So basically they are asking, okay, what is the sampling distribution of X bar of the itemized deduction of this population of taxpayers for each of the following sample size, right? So basically, you need to find the expected value of this this random sample, right? And then for each n, when n varies, you have to find the sample distribution of x, right? Okay. So let's just take a look at this problem. What is given is the mean amount of deduction for this population is, okay, so let's just, okay. Okay, so what is given? So let's just, if I just use this example, right? Let's just delete the previous calculations. Okay. So what is given is this mu, right? So let's just write it down. Okay, so what is given is the mu, right? Which is, the mu is given, right? So this side, population parameters is given. So what is given in this problem is mu, which is population mean is what? 16,642, and then sigma, which is a population parameter, right? Standard population deviation, right? the number is the what? Yep, the standard deviation, right? Population standard deviation is sigma is 22 or 2220. Okay, okay. So that's the given, right? So basically, you asking for the sampling mean. So basically, you need to find the x bar, the expected value of this x bar, right? So x bar means you can get this value from the sample, right? For example, as I already explained in my lecture, right? You have a population, right? And then you get this. Let's say you get the random sample, right, of size of n, right? So this is like a sample one, and then you get another samples, and you got another samples, right? You'll just do this infinitely, then you will, and then from each sample, right, you can get the sample mean, right? So also from this sample, you can get the sample mean, and etc. So you get the sample mean, sample mean. So if we draw the probability distribution of the sample mean, right, you know that we will have this normal graph, right? So we know that this is the x bar, right? But basically, expected mean is we need to find this the value, right? So this value means expected value, right, of x bar. And we know that this equation, is basically, we know that this is what? Simply the mu, which is the population mean, right? Okay, so if you're collecting this, like this, the what mean, right? Mean, if you collect all this mean value from this sample, right? So I know that this is like mean of a sample, right? So you get this mean from the samples, right? And we know that this value will follow the normal distributions, right? The mean value of x bar, right, is basically what? Same as the population mean, right? So the EX is basically same as the first one, right? This first part, the same as basically this value, right? You don't have to really calculate anything, right? Basically this one, right? Which is 16,642, right? Okay, now they're asking for the so the next problem is find the what? The standard deviation of this sample distribution. Okay, so basically this is called sampling so the name for this is what? Sampling distribution graph, right? Distribution of the x bar, right? Actually, the full name is a sampling distribution of a sample mean. Of a sample mean, right? That's a full name, right? So sometimes we call it sampling distribution of x bar or the sampling distribution of the sample mean, right? I already explained this in my lecture, okay? And okay, and the next problem is they're asking what is the sampling distribution of x bar? So sometimes when the questions ask you the sampling distribution of x bar, they're asking for the, okay, so the problem asking for the sampling distribution of x bar, right? When the sample size is 30, 50, 100, and 400, right? So then actually sometimes when the problem asks you for the sampling distribution of x bar, they are really asking for the basically the this guy, okay? This means, of course, the standard deviation, right, of a sample mean. So you know that this graph will have a x bar, right? The standard deviation of a sample mean, right? So basically they're trying to find x, right? And the equation for this is what? It's if the population standard deviation is known, right? Then you basically do a root n, right? Okay, so the first one, when n is a 30, right? And you can find this value, right? When n is a 30, we know that it's the root 30. And then the sigma is a population standard deviation, which is this guy, right? So 2220, right? And I think you can find this value. But you have to find this value, the standard deviation of x bar, right? For when n is a 30, when n is a 50, when n is 100, and when it's 400. Okay, so I think you can find this value easily. Okay. Okay, so next problem is similar. Basically, what is the sampling distribution of x bar? The same thing, right? When for a random sample of 50, the male college graduate. Okay, so to find, so next problem is we need to find, again, we need to find the what? Sigma x bar, right? And then we use the same equation, n, and then sigma, right? Let's say for this problem, we have the sample size 50, right? And then what's the sigma? The sigma is, by the way, this is for the male, right? So the, let's say for female, okay, so assuming the standard deviation for the male graduate is $2.30. So the sigma is, in this case, is the population standard deviation is in this case 2.30. Okay, this is for the male, by the way. Okay, so I think you can easily find the sampling distribution of x, which is this. Okay, so I can ask you either way. I can ask you what is the sampling distribution of x bar, right? Or I can ask you to find. I mean, there are two ways that I can ask you the question for this, right? I can ask you to find the sampling distribution of x bar. So that means you have to find this value. Or I can ask you for the standard deviation of a sample mean, right? And also you need to, that means you also need to find this value, right? Sigma x bar. Okay. Okay, so before we move to our next sections, I want to, so by the way, let me just clarify a couple of things. Okay, so this is the point estimation, right? Up to this point. So this is like a point estimations. And starting from this, we know that this is what? Now this is something called a sampling distribution. So the topic is sampling distribution of a sample mean, right? So that's a topic. And okay, so before I move to next questions, I want you to know the another notations, right? We learned this in our I discussed this topic in my lecture. Something called x bar, right? Is the same name. This is standard deviation, right? Standard deviation of a sample mean, right? But the reason that we put s instead of a sigma is that sometimes, I mean, it's most of the cases, the population standard deviation is not known, right? So we need to find the estimate value of this guy, right? So this is like estimated value. Estimated value of sigma x bar, right? And the equation for that is what? It's very similar, root n. And then instead of a sigma, we'll use just s, right? The standard deviation that we can calculate from the sample. So this s. right? So I just want you to know that the difference between the sigma x and then Sx bar, right? And so this is when the population mean is population standard deviation is known, and this when the population standard deviation is not known. In such a case, we have to just assuming that S is pretty close. This S is pretty close to the sigma, the population standard deviation. Okay. Okay. So so now the next topic. Okay. So now let's look at the next problem. Next problem said the Wall Street Journal reported that the age at the first startup for the 15% of entrepreneur was 29 years of age or less, and age at the first startup for the 85% entrepreneur was 30 years of age or more, right? So now, so suppose, let's look at the question number A. Suppose a sample of 200 entrepreneurs will be taken to learn about the most important the qualities of the entrepreneurs. Show that the sample distribution of P bar, where the P bar is a sample proportion of the entrepreneurs whose first startup was 29 years or the years of age or less, right? So now, basically, okay, so now so this problem is about the proportional, the proportion, right? So you know that previously I talked about the sample distribution of the sample mean, right? And from this, I'm going to talk about sampling distribution of what? A sample proportion. So the sample proportion, the notation is this, right? Sample proportion, right? As I explained. Okay, so sample proportion, right? This is sample P bar. The idea is exactly same for the previous case, the sampling distribution of a sample mean, right? The idea, this idea, right? This idea, right? So idea is what? So you have a population, right? So the populations, this is the populations, and then the population have some value, the population proportion, right? And you know, let's say this is like a 0.3, for example, 30%. And then you get the sample, right, of size of n. So this is a sample sample of size n, right? Size is equal to n. And then you calculate the mean, I mean the proportion, right? Mean the proportions, which is P bar, right? So let's say this is like P bar 1, but you just do this infinitely, right? So you get another samples, and then you calculate the proportion, right? The sample proportion. And then you can get the P bar 2, right? Because this is a sample, another sample, let's say sample 2 of the same size, size is equal to n. And then you can get another samples, and then you get another samples, right? So you do this like infinite times. And then every time you get the sample, you can calculate the sample proportions. And that's why you use the bar, right? And then I can draw the sampling distribution, right, which is the probability distributions, right? And then I'm gonna get this. So this is the normal distribution, right? And then this is what? The P bar, right? And then we know that this will form a normal distributions. And the name for this is what? Sampling distribution. So this graph is sampling distributions of sample proportions, which is P bar, right? So this is a graph, right, of sampling distribution of sample proportions. Okay, now it follows this graph, this distribution graph with the probability distribution. If you look at the mean, which is known as expected value of this p bar, right? It's exactly is the same as the p, which is population proportions, right? And then we can also, what we are interested in is to find the sigma, right? Sigma of this p bar, the standard deviation of sample proportions, right? So the equation for this is, equation for this is what? The n, right? And n is a sample size, and then p is, you can get this p from a sample, right? And then what? 1 minus p bar. So that's the equation, right? Okay. Oh, you know what? Actually, I made a mistake. Actually, this is okay. So the sigma, the standard deviation of the population proportion, right? The standard deviation, right, is equal to n, p, right? And then what? 1 minus p. This p is a population proportion p, right? Okay. However, the problem is just like the sample distribution of a sample mean. The problem is we don't know many cases, right? We don't know the population proportions, right? In our previous case, we don't know the population. The population standard deviation, right? In this case, this p-value is in many cases is not known. So to find a sampling distribution, the standard deviation of a sample proportion, right? We need to estimate this value, right? And that is known as S and then p bar, right? So basically this means what? Estimated the value of sigma p bar, which is this one, right? And instead of a p, we are going to use the what? P bar. That's the value you can get from a sample, right? So this is the equation for this is, oops, it's too thick, is what? It's very similar, just n. So instead of using p, use a p bar, right? 1 minus p bar. Okay. So just like in the previous case, I want you to know the difference between this and this, right? Which is estimate version of the sigma x bar. They're very similar. SP bar means estimate value of sigma p bar, right? So I want you to know the difference between these two, right? Okay, having said this, now let's take a look at the problem, right? Okay, having said this, now let's take a look at the problem. Basically, what is given, okay? So what is given is 15% of the entrepreneurs, are like 29s or the less, right? The 15%. Okay, so the population, right? The population proportion given, right? The population proportion given is 0.15, right? And of course, okay, so suppose that, and then let's see, yeah. And suppose that sample of 200 entrepreneurs will taken to learn about the most important the qualities of entrepreneurs, right? And show the sampling distribution of a p prime, where the p prime is sampling proportion of entrepreneurs whose first startup was at 29 years of age or less, right? Okay. So basically they're asking to find the sampling proportion, right? So basically when the questions ask you to find the the sample in a proportion, right? The sampling proportions, right? Basically, they're asking you to find the sigma p prime, which is this value, the sigma p prime, basically. Okay, but if you look at this problem, they're asking you to find the NP. Okay, so first oops. So they ask you to find the NP, right? And I don't know why they're asking this problem, but N is what? The 200 samples, right? So basically, it's one of the sample, right? So basically, the samples, right, is N is 200. This is given in the problem, right? And then you know that in they ask you to find the they're asking you to find this P prime, right? So what is it? Actually, expected value of a P prime. So they're asking you to find the expected, right, value of this. Okay, hold on. Okay, so expected. Okay, so to be precise. Okay, so this is given, right? And basically, you know, let's say this is N1 minus P. And if you look at the third problem, they're asking you to find the E P prime, right? Which is this, right? And we know that this is same as the population proportions, right? Which is 0.15, right? Okay. Okay, so the third problem is done, and then if you look at the fourth problem, okay, so I'm gonna go back to the first and second later. But let's just first find the problem number 4, which is a sigma, right, of P prime, which is a sampling distribution of a sample proportions, right? Or there are many names. For example, if you look at the next problem, they're asking you to find the sampling distribution of the P prime, right? Then, okay, so this is like a many names. Okay, so if you know, if the problem asks you to find or identify the sampling distribution, right, of P prime, basically they're asking you to find this value, which is this value or the S prime, right? The S P prime actually. So this another name for this is what? Standard deviation, right, of a sample proportion, right? So which is just P prime, right? And sometimes they ask you to find the SP prime, right, which is estimated standard deviation of a sample the sample proportions, right? And to find the value, what is the equations? N and then P and 1 minus P. Since we know the P, right, which is 0.15, when this is known, and definitely we can use the standard deviation of a sample proportion, we can find this value, right? However, when the P is not known, then we have to use this SP prime, right? And which is shown. And we have to use this equation, right? Okay, so anyway, so problem number 4, you can find this value using this formula, right? Root, the square root, and then numerator is P multiplied by 1 minus P, and divided by N. Okay, so we know that N is given, right? In this case, N is 200. So I think you can definitely find the value, right, using the calculator. Okay, now let's go back to problem 1 and 2. I don't know why. Okay, so basically the NP, right, is really give you the number of entrepreneurs, right, when you have, let's say when you have 200 entrepreneurs, right? So if you get a sample of 200 entrepreneurs, right? And so the 0.15, right? So this is, I think this is a 30. So what that means is when you have a sample, right? Let's say when you have a sample of 200, right? Among 200, expected value of entrepreneurs whose age is 29 or less, right, is 30. So let's say this is a sample of 200. Among 200, you know that there's about, I mean, usually, right, on average, there are 30 entrepreneurs whose age is less than, I mean, equal or less than 29. Okay, so remember, this is, I know in previous chapters, right, we learned about binomial distribution, right? So if I just formalize this a little bit, let's say x, let's say random variable x represent, let's say the number of entrepreneurs whose age is 20 or less. If we define the random variable x, right, like that, then so basically, so that means expected value of random variable x is NP, right? Remember that formula? When x follows the binomial distributions. Okay. So why this is binomial? It's very simple, because why the x is a binomial, like a random variable which follows the binomial distribution, right? Reason is, you know, the binomial means what? Binomial is either 1 or 0, right? Or the true or false, right? In this case, entrepreneurs whose age is 29 or less, right? Or the 29, I mean, let's say 30 or more, right? Their age. So basically, this is think as a 1, and this is think as a 0, and true and false, right? There's only 2 events for this random variable x, right? So that's why we are assuming that the random variable x follows the binomial distribution, right? When x follows binomial distribution, the formula, right, for the expected value of the x is NP, right? And obviously this is n times 1 minus p means, so let's say 200 multiplied by 0.85, right? And then if you calculate, I think you will get probably 170, right? So this number is, let's say, the random variable y is, you can think this way. Let's say random variable y is also the binomial distribution, follow the binomial distribution. So in this case, y you can define as number of entrepreneurs, right, whose age is, let's say, 29, right? Yeah, 30, right? 30 or more, okay? So we have expected value of y, in this case is n minus 1 minus p, right? So this case, we can define random variable x as a number of entrepreneurs whose age is what, 29 or less, right? And this random variable y is number of entrepreneurs whose age is greater than 30 or the greater, right? 30 or the greater. Okay, so basically that's what that really means. And of course, random variable follow binomial distribution, because y means when there are only 2 events, right? Whose age is less than 29 or less, and then 30 or more, right? So it's 1, 0, true or false, right? Okay. So that's what it really means. Okay, so basically that's it. Okay, so pretty much I'm done with this problem 6, and let's move to a problem number 7. The problem number 7 is basically show the sampling distribution of the p prime, right? So basically, they're asking you to find this equation, right? This one. Okay, and since the P is given, let's see, because there are 12% of what they buy at the grocery store, they're tossing. So the P, which is 0.12, is a population proportions, right? So this P is given as 1 point. So the next problem 7. Okay, so if you look at the problem 7, they're asking you to find the sampling distribution of the P prime, so which is this value, right? The sigma P is N P 1 minus P, right? And we know that this is 1 minus P. And we know that P, the population proportion, is 0.12, and then N is what? In this case, N is 540, right? Okay. So you can get the sigma P prime, right? Which is sampling distribution of the P prime, or is known as standard deviation of sample proportion, right? Okay. So I know that solving the problems are not too difficult, right? So the formulas are relatively, they're all simple, but I want you to know that the concept. It's not just solving the problems, right? So the first, they're talking about the point estimators, right? The point estimators, that's the main concept, right? So that's and then the next, the thing that you have to know is, the concept that you have to know is a sampling distribution of the sample mean, right? And then the third concept that you should know is what? Sampling distribution of the sample proportions. Okay, so there are 3 main concepts that you should know. Okay, thank you.